Guess not. Oh well. Okay, I needed coffee. Ooh. We all do. Oh, hey, Mario. Thanks for dropping by. All right. Good morning, good afternoon. How's everyone doing? I wanted to try this out in a time slot that maybe was more conducive to my friends across the pond. I was trying to get this running for LinkedIn as well, but I was unable to get the stream key to work, and I don't know why. So If anyone knows LinkedIn, maybe we can try and refresh this and try it again. Let's see if it'll let me. One more time, we'll try going live. Pick a region. Okay, let's try US Northeast. That's where I am. Y'all don't sleep on LinkedIn. There's a bunch of people there that don't sit on tech Twitter. All right. Well, I'm not going to try that again. Are we back? I think we're back. We should be back. Okay. Maybe that's why you do sleep on LinkedIn. Anyway, I think Dax and Mario both responded to my tweet with different answers to this, which I think is hilarious. So I want to see the difference between if you package a bunch of dead code into your Lambda function, does that end up impacting your cold starts or not? And I have a really good hunch about this. In fact, I've got a certain amount of evidence already for this, but nothing, like all anecdotal, nothing that I can present at a conference, which is, again, the point of this, to try and prepare for this talk that I'm going to give. So we got a couple of things we have to do here. We already have a number of attempts at benchmarking cold starts with different size payloads, and we know we've like a very good representation that approximately every 10 megabytes you add to the payload size that you're actually loading, or like every 10 megabytes your Lambda function loads, your cold start increases by about 100 milliseconds, roughly. So what I want to do is try to work out if that holds true entirely for code that we don't load. And I don't think it does. I haven't seen it, in fact. But let's find out. And we already have all these example projects anyway, so I think this should be fast, which is good because I do have to work today. Okay, so we've got all of these different size packages that we've created, and we've got all of these different templates that we've already set up. So I think this should be straightforward enough to get cooking. Let's go to our dead code. CD non-loaded. And then let's do the 250 megabyte Node.js to here. Oh my God. I do that every time. And I left my normal keyboard at work yesterday, so bear with me as I figure out the function keys on this 10 keyless keyboard that I'm using today. How's everybody doing? I think there's like 2 of you here, but appreciate you hanging out. I have to wrap up all this data collection very soon. All right. Experimenting with OTel and OpenSearch. Nice. That's awesome. Okay, so we have this, let's just make sure we don't have anything crazy in here. Okay. So this handler, oh, okay, I don't care if that git query is deprecated. Thanks, tree sitter. So let's comment out all of the wrong languages. He's building Docker all day. Okay, so we'll comment out all these imports, but we are still going to push this code into the package. Actually, let's make sure we've got this right. Yeah, styled material UI. So we're just throwing a bunch of dependencies in here, just a bunch of crap. We have the AWS SDK, we have React DOM, we have serverless, we have material UI, and emotion styled library, which is on a version 11. Holy smokes. I guess React DOM's 18. Okay. Let's package it up. And I think we've got, oh, this is, okay, let's just go to or let's start with 1024 megabytes of RAM, and we can see. Nice. I'm bummed that LinkedIn Live didn't work. That's really annoying. I have to figure out why. Some people have figured it out. I don't know why it didn't work for me. All right, we got our first CloudFormation deploy of the day. Okay. So first things first, let's go into that serverless directory and let's unzip the service. There's a lot of code there. It all packaged. That's exciting. 231 megabyte. Okay. We should do an iteration first, right? Oh no, function size. Okay. It's a little confusing. I think I've referred to function size and payload size sort of interchangeably. I want to come up with canonical terms for that. I think I would say either like loaded function size or just function size for the code that your function requires when it starts. And then I would probably say, you know, payload size or zip size for things that aren't, which maybe that's too confusing. It's not clear enough. Maybe. Okay, so this is 231, and let's see what our in iteration is. Oh. Okay, and now I need to log in. If you haven't done this before, you're gonna want to make sure that you're using a non-root account role to log into your AWS account, your personal AWS account. This is going to prevent you from accidentally leaking your keys and have someone who can make changes to the billing or credit card on your account, and a number of other things to access CloudTrail. Oh, shoot. Okay, I just accidentally redeployed over the old one, so I don't want to do that. I'm just going to deploy a new stack. Then that's fine. While we're doing this, I'm going to try to figure out why this won't work. Why streaming to LinkedIn won't work. Oh, that worked. That's awesome. Okay, well. Welcome to LinkedIn Live, everyone. That's neat. I guess it was the wrong region. All right, that is our deploy. All right, multi-streaming. That is a lot of work, but kind of neat. Cool. All right, the chat is still Twitch, so thanks for anyone who's joining from LinkedIn or from YouTube. You'll have to go to Twitch if you want to chat with me. I'll try and click through the tabs, but I'm not good enough at this to have any help or any hope of doing that effectively. So, but I wanted to make sure I've got a number of people that follow me only on LinkedIn, and I want to make sure they have an opportunity to see some of the work we're doing, especially if you can't make it to reInvent. All right, so what do? We are testing to see the relationship between your Lambda function size and your cold start times in AWS Lambda. And to make that work, we've been, over the last couple of weeks and the weekends, have been running suites of benchmarks with different runtimes. We've done Node and Python and now Bun, and we've done different sizes of dependencies, different dependencies in the Lambda function. So what I want to make sure now is we know already today roughly there is a linear relationship between our payload size and an iteration. So that's information we've already collected. We can roughly do the math and say, okay, for every 10 megabytes your function loads, roughly you're going to add another 100 milliseconds of cold start duration, maybe a little less here in Node. But we start to get 1-to-1 towards the end, right? Because we're 2,500 milliseconds and 250 megabyte payload size, which is, I mean, it's just a good benchmark to have. But now what I want to figure out is, what does that mean for code that I don't load, right? So if I just have a bunch of code in the zip file but don't load it, maybe a large CSV file that I don't necessarily need, or maybe something just got in there accidentally, which happens all the time. I want to see how that impacts our cold starts. So we've unloaded code, we have 231 megabytes. Let's take a look. All right, unloaded 250 megabyte hello. It's technically 231. All right, so that's 169 milliseconds, which is significantly better than what we saw on the top end of 240 megabytes and 2,500 milliseconds. So that is a pretty definitive answer, which is good because it's an early stream. Dax called this right away. That's been my experience as well, but I want to, for the sake of collecting good data, I want to work through this all the way back down. So let's see, do I not have a 200 megabyte node? I do, yeah, cp-r 200, and move that into non-loaded. Okay. Oh, it's empty. Okay. Well, that explains why the copy didn't work. Cool. All right. Now let's try and hit 200 megabytes. And I think we've done this, so we should be able to look up what we've done, because we try and be good math people and write down our work. 181. Okay, of course I didn't. I think this is just serverless framework plus AWS SDK. So let's try that. The reason I test these is I see this all the time, and actually this is a very common thing to do accidentally, is maybe you just need the SDK, but probably once a month I see somebody that has packaged the entire serverless framework as a dependency because they are new to NPM and accidentally put serverless in their dependencies instead of their dev dependencies, and that just happens. That's I don't know. There's like a pretty classic accident, unfortunately. Mario says, I have a Python container on Lambda with more than 1 gig and it's average 3.5 seconds. I'm sure. Okay. Most of the things are not loaded by the functions. That's true. Containers load differently. And I think that's the key takeaway. The containers have a special caching system and a special even like deployment system. So we can talk about this. I was going to do a stream last night, but it got too late and I wasn't going to have time. This is a great talk and it covers it right here. There's this like,
in that code payloads were now
there's this entire
larger.
Session from reInvent.
While zip code payloads are limited to 250 megabytes
yeah, I'm
in
using
size,
a Moonlander. That's why it's so loud.
we realized that container images are often much larger, and we decided to support.
Definitely get it true. I've had a number of wrist issues over the years, and it solved it for me. Today I'm not on the Moonlander. Today I'm on a Poker 3 because my Moonlander is in the office. I forgot to bring it. So I'm just gonna plug this talk really quick in the chats. Can I put it in LinkedIn chat? Okay, so I've managing multiple chats. I'm sure there is a plugin for this. I should know this. Okay. I'm not gonna have time to watch this today, but I want to, and maybe I'll do this on stream later this week, maybe Saturday when I actually get time to stream. But I gotta stay focused today. So great talk, and yeah, containers are loaded differently, Mario, and that's I think a big part of this. I wonder, and I think the open question now is it similar to, like, are those optimizations something that are just made for containers? In that way, yes, the answer is definitely yes. But are there similar optimizations for zip files? That's a good question. Like, is there a way that they do multi-tenant conversion encryption and deduplication so that we can share each other's like dependencies in blocks of 512 kilobytes, which is what happens for container images. Okay, let's install the SDK. Quick 94 megabytes, 92 megabytes. Okay, and install serverless. That might be too big. Actually, that might be like 200 something meg. $181. Pretty close. Pretty good. Let's take that just as a measurement. It's close enough that we can get a good point off of it. Unloaded 181. Okay. Sorry, I know that's probably a little hard to see on all the various platforms. Thanks for sticking with me. Let's find out. We need to rename the service. Oh, it doesn't have, okay, yeah. So we need to rename the service. We need to give it a events, HTTP API, method get. That path needs to be slashed. All right. The zip is probably way smaller than the unpacked data. Yeah, remember that the unzipping part is going to happen out of band, though. As far as I know. And maybe, and I want to be able to prove that, actually. Or maybe I should just ask them. As far as I know, the code is unzipped when it goes from an S3 bucket into Lambda code store. Maybe it's not, though. I mean, it wouldn't surprise me. I guess that's probably not the case, right? Because AWS is notoriously stingy with bandwidth, and I guess it wouldn't surprise me if they are like re-gzipping it or something to get it to the worker. Yeah, you're probably right. There's probably like other zip steps, probably more than one. All right. Sweet. Okay, that looked pretty fast. Let's go into our zip file. Yeah, so okay, good. I've had a couple of packaging bugs with the serverless framework, and this is why I like to check. So you can't cheat the zip. So okay, let's find out what our cold start was here. And we can repeat this process, and we probably should repeat this process. But my plan is to get all of these functions deployed and then make them cold start over and over again with the script, so we can kind of keep a live running total. All right, so we cut, we cut 50 megabytes off of that zip size, and we saw virtually no change in the init duration. So I'm feeling pretty confident that there is no relationship between, that the relationship between cold starts and function size is only apparent and matters when you're loading that code, which is good. I did write a blog post about this, so it's not like this is entirely new information. I've never definitively collected it in this manner before, and that's why we're doing this. If you want to learn more about this, you can check out this post on lazy loading and cold starts. What I'm talking about here is a very trivial example, probably too trivial. I should have done something more impactful. However, we know that loading individual clients is going to be an optimization we can make with the AWS SDK, and we also know that if we don't need a dependency, not loading it will improve our cold start time. So there's these cases where you can conditionally load dependencies. And the idea behind this is let's imagine we have an API that has, all multi-tenant SaaS apps, you've got a Justin Bieber, right? You've got a diva on your platform, or not, whatever. You have somebody that has special needs that needs either a additional database write on a call, or maybe you're in this case you need to publish to SNS, right? So what's happening is typically for 99% of our customers, we're going through Lambda and writing to Dynamo. It's a REST API, super simple. However, in the Justin Bieber case, or in the AJ case, I should pick on myself. This person needs a message written to SNS that is going to go somewhere else, right? Maybe they just have they get a text message or something every time an API call occurs. When this happens, you're faced with this choice, and you can conditionally import code that you don't necessarily need. And the advantage is that you can, the advantage here is that you can load that code only when that user is receiving a call, because for some segment of warm Lambda sandboxes that are being run, you'll never need this SNS call. And then we can measure it, right? So we know that it's a 400 millisecond cold start to load Dynamo. We know that on top of that, SNS requires another 50 milliseconds, so we can just save those 50 milliseconds. And to do so, we can wrap this in a method called load SNS. And then we can only call that if my request comes in. And then we can see, you can see that now that cold start's much shorter. It's about 50 milliseconds shorter. And we can also see that when a request for AJ comes in, you're going to get that 80 millisecond penalty. The question as to why is it slower to load a dependency when the node process is running versus upfront during init? I think the answer is in two parts. One, you have to stop or pause the event loop when you load dependencies, or at least in CJS you do. So that is gonna stop as well. But I think the biggest thing, and I don't know, Michael Hart just liked my tweet, but I don't know if he's here. Michael Hart did a good blog post talking about the amount of CPU you get per runtime, the amount of CPU you get per memory config. They just, in their docs, AWS just says they're linked. They don't tell you how many vCPUs you get at any memory point, except for one, which is 1782 megabytes or 1.7 gig. You get one unthrottled virtual CPU. And this function was using less than that. So during the runtime, after init, you have less CPU power, which means it's going to take roughly more time to load a dependency. But this is an option you can pursue. Depending on your memory configuration, this is going to be more or less useful. I'll drop it in the chats. And let's get our data. Okay, so that was 176 for 200 megabytes. Let's keep ripping through and creating new services, and then we can call them later. Do I have 150 known? Every time. One day, actually I should just alias that command because I keep missing the -r. MV, you don't need recursive, and CPU do. Okay. What's in this? Oh, just SDK. Okay, that's 181. So that we rounded that up to 200, but let's remove serverless. And then what dependency should we use? I think what we can do, so we should be able to do IMDb data. Oh, I made a syntax error. Okay, let's try that again. Okay. Yeah, Mario, that's my hunch. My hunch is that, so Mario said that the zip is unpacked on S3 and only transfers what you're loading, and that's interesting, and then Dax will be right. That's my hunch. I've not confirmed that. I'm going to reach out to the Lambda team, a couple of friends that are there, or a couple of people I know that reached out after my last blog post. I'll ping them and see if they want to comment on any of that. I'm sure, I would say, just like I've said on every stream, like the results from these little benchmarks are only valid for today. Tomorrow, or even in a couple hours when the West Coast wakes up, they might be deploying some big change, and you're going to get, some new initialization path, some new caching, some new, algorithm change that's going to affect this. So what I want to do is just give people the tools to do this themselves. And yeah, we can, the other thing we can do, right, is all these functions don't cost me any money to have deployed, which is one of the things I love about Lambda. So I can just deploy these, and then I have another function that we can build, or I can build, copy some bits from another function and build a service that just invokes these and causes a cold start every couple of days. And then we can just, if back when Twitter had an API, I could just tweet that, but I guess we can do something like Max does and share those benchmarks on like a daily basis and just see. This is good. 155 megabytes is great. So let's deploy that. Did we rename the service? I can't remember. Yeah, unloaded 150. Okay. All right, this is a good data point. 155 megabytes. Let's find out. And this is IMDb data. So I'm just recording which packages I installed to make it really easy to find them for other tests. All right, Mario, I added you on LinkedIn. We're still uploading this code. This is great. I feel good about this. So I've got a couple of other key questions I want to answer, and like definitively, like the point of this talk is to answer a few key questions. The first and foremost we've already done, which is how much does package size matter? Or I'm sorry, that's technically what we're doing now, right? Like how much does the actual size of the zip file matter? Then the second is how much does import size, the bytes that I actually read, how much does that matter? The next question, which Lambda power tuning can answer, so I'm a little less keen on that, and I also sort of know the answer. How much does your RAM configuration matter? Which is a big one. I mean, that is something that we can talk through. However, I'm not aware of any runtimes, Go, Rust, or otherwise, that have like multi-processor or multi-core initialization. I'm not sure how you'd even do that. I think it would be actually my hunch, totally uninformed hunch, would be an advantage for Lambda functions, because reading those bytes, well, I/O is a slow part because these bytes aren't on a local disk; they're on some network store or some tertiary store like S3 that have to be streamed into the sandbox when they initialize. So if you could have like multiple connections loading less code, somehow your abstract runtime, your Lambda function knows that, okay, during init we're going to have 10 cores because it's a 10 gigabyte Lambda function, or 7 cores or whatever it is. So we'll start 7 processes that all can max out the I/O of 7 of those devices. And that's another question is how many file handles, how much network do we get on a Lambda function across memory? I don't know. But doing that, would you improve cold starts? I think the answer would be yes. But I don't know if that's really possible to do, because at some point you have to share state. So if you have, multi-core process that actually has to share state, you're going to have to introduce locking and mutexes. And then at that point, it may not be any faster than just like what most people do with Python or JavaScript or Ruby, which is run like a process per core on a server. Okay, so that's 150 megabytes. That's our cold start. Couple more. There we go. 180 milliseconds, so no real change here. There's some fuzziness, of course, and that's totally fine, but pretty flat overall. Okay, AWS SDK is 92 megabytes, 94 megabytes. Let's just do that one. Mario says, for Go, I use a single binary. Last one was 18 megabytes and a 5.5 zipped 5.5. Oh, cold start around 130 milliseconds. I think that makes sense, right? So what did I say in our other benchmarks? It's approximately 10 megabytes is 100 milliseconds. Maybe a little bit better for Go, but not out of the ballpark, right? Your maybe Go is a line like just a little flatter here, where you get a little bit more payload size for a little bit less in duration. We can find that out. I've got a couple of Go projects. And Mario, if you haven't, one thing you can look at is UPX to pack your Go functions. If you really don't care about cold start, or if you have like more time to shave off and you need more dependencies, UPX is a really cool technology that allows you to pack an executable, and it's in place. So if you think about the ELF file, the executable file for a Lambda, for any binary on a Linux machine, what they basically do is compress your binary and then put their decompressor at the top of that ELF file, so that the first thing that happens is it decompresses in place when you execute that binary, which is neat. I think it's it's a super cool trade-off. It's definitely something that if I was building entirely on Docker and I wanted to maximize like my copy time into like a K8s environment, you might be able to do something about that here. Caveat being, I have absolutely no idea what compression technologies are available for container images into Kubernetes. Okay. This is easy enough to do. Okay, create a new serverless function. So we're going to just install the AWS SDK. We know, after hundreds and hundreds of attempts that the AWS SDK is 92 megabytes in total. The V2 SDK. I really think that the serverless framework modeling events like this, where you can just string an array of events in a YAML file. Like if you were to distill the success of the serverless framework down to one thing, it's that. It abstracted these complicated triggers and these different CloudFormation dependencies all into just an array of events and metadata about the event. And I think that is I think that's the mental model people innately have. And then to build a tool that reflects that mental model is what's going to grow naturally with most users. And that's why this took off. Because, fundamentally, we're just generating CloudFormation here, right? Like, all we're doing is generating a giant JSON file on my machine on this box. So it's not like it's that much different than just pure CloudFormation, and you could just write that if you wanted to, but no one does. All right, well, I shouldn't say that. People do, but most people I know don't. All right. Once again, updating CloudFormation. All right, Mario writes JSON for CloudFormation. I mean, you do a little bit in the serverless framework too. Oh, shoot. I named this wrong. Darn it. I did it again. So I just overwrote my other functions, which I need to remember and fix before I start invoking these randomly. Cool. So if you're just joining us, we're benchmarking a number of different configurations of Lambda zip file sizes, but we're not actually loading that code. And I'm doing this because I'm going to be presenting this data at reInvent for a talk. If you're in Twitch, !reInvent, you can see some of the information there. If you're going to be going, let me know. That'll be awesome. Oops, I accidentally clicked this, so we got a cold start already, but let's hit it. Okay, so that'll be that'll be a warm start, but we can still get the results from the cold start. Yeah, so we're at 92 meg. That's great. Come on, CloudWatch. Oh, wrong one here. Unloaded. Hello. Perfect. So there should be a couple of events here, and there are, because I accidentally clicked the link instead of curling it. 173.96. So again, we're totally on track, which we can pretty much say definitively that we have a virtually unrelated correlation between the zip size and the init duration, which tells me that if you don't load the code, you can, stick it in Lambda and not worry about that affecting your cold starts. The reason I think this is useful is especially for people who are building or moving from a container-based application on Fargate or EC2 to Lambda, you can lazily load some of your dependencies or conditionally load some of your dependencies in these like monolithic Lambda applications, right? Where you drop like an Express app into your Lambda function. If you've got all these code branches in your code that are executed for some requests, but not all the requests, this makes a lot of sense to do. And you can then offload some of that time and sort of split it, which is sort of a benefit, because if you think about it, I'd rather have the fastest cold start possible when I know I have to load the bulk of my dependencies and cut as many of those out as I can, if that request isn't going to need those dependencies, right? Like if that incoming request isn't going to need it, then I just load what I need, run the request, problem solved. And if the request is going to need it, we can then just load them at that point. which then sort of splits that pain of the cold start across, and that's going to bring our P99 or our latency down from a larger value to 2 instances of smaller values. In theory, we've shifted 50 milliseconds from user A to user B, but in aggregate, that'll improve our P99 significantly. So this is great. Okay, we need a 50 megabyte dependency. The answer to that is IMDb data. That's about 55 megabytes. Okay. Create another app. All right, this will be, we have 2 more runs to do, which is good because I have to start work. Okay. I should have named these directories with unloaded, and then serverless would have called them that by default. Okay. Method get. Ugh. This looks good. All right, so we're installing a package for IMDb data. It's 64 megabytes, so we'll take that. Run that deploy. Coffee is finally hitting. I should have had the coffee before I did this, but oh well. Evac Ram, hey, how's it going? Thanks for dropping by. Sorry, keep forgetting. If you're joining on LinkedIn or YouTube, thanks for hanging out. I've got a chat plugin for Twitch, so you'll be able to see that right up here. If you want to chat with me, go ahead and drop questions in Twitch. Happy to answer any questions about AWS or serverless, building on the cloud. Absolutely, bring questions, bring feedback. And if you're just tuning in for the first time, hit that follow button. That helps me out. Appreciate it. To recap where we're at, over these last 5 weeks, we've done kind of 4 or 5 benchmarks. We've done benchmarks for init duration for loaded code for Node and Python, and we found roughly every 10 megabytes of dependencies you load, you're going to have about 100 milliseconds of cold start time. Container images are a little bit more sporadic, and they have a lot more variance. And I think that's the biggest thing that I want people to take away, is that the variance for container images is greater, but you can get colder or like faster cold starts because of the caching technology that AWS has built. We talked about this paper a lot. I want to share it here. On-demand container loading for AWS Lambda. I'll drop it in. I'm looking at LinkedIn right now. I'm going to drop it in the LinkedIn chat. This is a great paper. So definitely check it out. And the key thing to understand is they are able to do what's called convergent encryption and cache share, like cache blocks of code in 512 kilobytes that you and I both may have in common, which is sweet. So that's how they do this, deduplication without trust bit. And the final element of this is this tiered cache. So there's a local cache on each worker. Then there is a cache in the availability zone. So in each data center, physical data center, you can, the chunks of your container image are going to be cached there. And if they're not in that cache, they're going to live in S3, which is their authoritative or canonical source. So they've got these L1, L2, L3 cache bars, which is really cool. And it shows you exactly how much you'd expect, like the performance of each that you'd expect based on the percentage of chunks available in each cache. And there's also like some bar here, some error bar about what chunks would be there or not. So once with a container image, if you're got a very active function and it's also chunks that other people are using, you're more likely to have cache hits, which means you're more likely to have much faster cold starts, which we found with Bun. So Bun is a new Lambda runtime. I'm sorry, a new runtime for JavaScript. And with a custom runtime implemented as a container image, we've gotten cold starts as low as 120 milliseconds, which is really, really, really fast. Super, super impressive for Bun. Two advantages there. One, you can pre-compile your entire application and Bun together in one binary and then just start it, which is great. That maps to Lambda really well because we don't have to spend time interpreting those bytes when your Lambda function begins. However, there's a lot of variance here, right? Like you can see that in some cases with the same code, we went from 120 milliseconds cold start to a 1 second or 1000 millisecond cold start. And a huge part of that is huge part of that is just the variance in those caches, right? And I think that may have even been, maybe that's like an L3 cache, like that's pulling from S3. But when you have a warm cache, you're gonna get a much faster cold start, even with a custom runtime like Bun. So today, what we're doing is just seeing what happens if we don't load any code. We have code in the zip file, but we're not requiring it with Lambda in our Lambda function. And I'm using this to simulate a case where you might think about lazy loading your functions. Maybe you have, a Lambda function that serves multiple types of requests, and on most of the requests you don't need a heavy dependency, but on one of them you do, and you can actually defer that load time to after initialization when that request comes in. So that's what we're benchmarking. All right. Oh, Evac, thanks. I appreciate it. I'm good, but thanks for dropping by. Sorry, I just switched back to Twitch chat. Okay, so that's great. We've got 64 megabytes of node modules, which is just a JSON file. We're just not loading it. And let's find out what we got. I'm guessing it's going to be 180 milliseconds. What do you think? 156. That's great. That's a great result. And one more benchmark. And it's just going to be a vanilla node function. Just hello world. Okay. Cool. I bet no payload is fast. I mean, watch there be variance and watch it hit like 200 milliseconds. Let's find out. Oh, thanks for dropping by the way. And for everyone who's joining, I know people are here on podcast mode, just enjoying the beats and my voice, I guess. I hope not, but help me out, drop a follow. That helps me out, helps get me a little bit higher in the Twitch rankings and YouTube and LinkedIn rankings for where people would be able to see the stream. I'm working on a reInvent talk in Las Vegas. It should be a lot of fun. I think the schedule should be out today, actually. And we're going to be talking all about Lambda, cold start, and initialization. I think a lot of these questions have been answered anecdotally, and a lot of these questions are sort of intrinsic knowledge for the community, but I want new developers to see that they have a lot of options when it comes to managing their init and their cold starts. And B, I want to collect good data on it and actually be able to present on good data, which I think we have a lot of now. The hard part after this is going to be cutting down the content. We are using new pre-warmers for functions. It's very nice. No cold start. Can you, is it Kochi? I still haven't figured out how to pronounce your name, but if you could drop a link to the warmer service you're using, that'd be great. I don't know if you're using like the serverless warm-up plugin. The other thing you should look for, everyone should look for, is how many times AWS Lambda is warming up your Lambda functions for you, which can occur. We call them proactive initializations. If you haven't read this post, I'll drop it in the chat here. Proactive initialization occurs when AWS Lambda inadvertently creates an additional sandbox for you as like a spillover. And this can happen when multiple requests are sort of flying in at one time. The easy way to explain this is there's a Lambda control plane. Imagine we have 2 requests coming in. So request A is already running in sandbox 1. When request B hits the Lambda control plane, there is no available Lambda sandbox to run your function. So what happens is Lambda begins initializing a new sandbox, sandbox 2. However, while sandbox 2 is being initialized, request A finishes and returns. So the Lambda control plane sees that an available sandbox is ready for request B, and it routes request B to sandbox 1, which is warm. So it's a warm start. Now what happens is you have sandbox 2 that was spinning up for request B, but no longer has any function to serve. So it's sitting there warm. It's pre-warmed. And what happens is later on, request C comes in and experiences no cold starts, even though at some point we triggered a cold start. Oh, it's just functions on our EC2 servers, no Lambdas. Yeah, of course. I mean, you do have cold starts though. So like, this is a thing that I harp on Twitter a lot, which is even if you're running, and the service my team supports is running in K8s. Even a K8s service, you have to start your application, which means if you have an unexpected crush of traffic, right? You have like the Taylor Swift tickets or the new iPhone launch situation happen to your users, you're going to have to initialize new versions of your app. You're going to have to spin up a bunch of copies of your application to respond to that traffic. So if you don't care about your cold starts, or you don't care about your application init, users are going to have a bad experience waiting for those additional app servers to scale up. Yeah, true, exactly. And you know this. I mean, we how many people tweeted about the App Store or the Apple Store when the new iPhone came out? It was all over. It was like the top of Twitter, top of Hacker News. Like, you know, how is the store crashing, whatever. And the like, while they're spinning up these additional instances, customers are having a bad experience. That is a cold start. I want to encompass. It doesn't matter if it's serverless or server full. Application initialization is something you should actually think about. It's not something, it shouldn't be the only thing you worry about. It shouldn't be the first thing you worry about. It's just something you should consider in the same way you consider test coverage, in the same way you consider, code quality and technical debt. It should be something you think about, something you know, and something you're able to keep an eye on. So that's my pitch. That's my elevator pitch on application initialization. It's important. You got to keep track of it. All right, so we just caused this cold start. We know that this should be, roughly 180 milliseconds. Otherwise, something's wrong with our trend. 182. Bang on. All right, let's draw the graph. Oh, is it going to be mad at me? And okay, there we go. Is this the same? I want to make sure I use the same axes. Yeah, an iteration function size. Look at that. That is data. I love seeing that. All right, so what do we learn today? What have we learned so far? It doesn't really matter how big our Lambda function is if we don't load that code. Marios is proven. Yeah, exactly. Like we've proven this. We figured this out. This is great. This is a good result. I love how consistent it is. We can probably do the same thing with Python. I think it'll be the same. Mario, we learned that, hey, man, I'm wrong all the time. My default state in life is wrong, and then I'm trying to back it up and figure it out. So I think we can make a bunch of conclusions from this, though. And I think the first is definitely look into lazy loading if you're having problems with your cold starts and you have a non-binary runtime. So if you're using Go, this is a problem because that Go binary is one giant file, and Go will want to load its entire runtime, which is quite large, and all of your binary file before it can start. As far as I know, unless you add like a foreign function interface or what else would it be? Like, I mean, you can like dynamically link a Go binary, which I don't think you do or can. No, you can. You totally can. Regardless, I don't think it's a default, right? Because Go ships with its own kind of implementation of libc, and I think you can link against it though. Okay, I don't know enough about Go to be right here. So regardless, for Python and Node and Ruby and PHP, you should look into lazy loading or cold starts. No, LDD, no seed linking. Okay, that's right. I was thinking about, I don't remember, whatever. So if you have a Go function, you really got to think about splitting up that binary into smaller functions, and you probably already do if you're writing Go. But it's a good thing to think about, because these options that we've laid out here today aren't going to be something you can take advantage of, because all of those bytes are going to have to hit the Lambda function before it can start. Whereas in this case, we can jam 230 megabytes of dependencies into a Lambda function, and it'll still start in 170 milliseconds as long as we don't load that code. So if you're looking for more resources on this, check out my post on lazy loading. Check out my post on proactive initialization. We can discuss this more on Twitter. I want to share this, but this is great. I'm really happy with this result. Really, really happy with this result. This is good. And if you're new here, if you're just dropping by, it helps me out if you drop a follow. Click that follow button. I really appreciate that. This is awesome. I'm just so pleased with this result. Like, it's hard to be mad about that consistent of a cold start. Hard to be mad. So the answer is this, right? The answer is basically nothing. Basically no difference. And that's why we can lazily load, and that's why we can take advantage of those asymmetries and have a little bit more optionality when it comes to building Lambda functions, which I think is great. Cool. All right. I think that's all I have today. I really appreciate everyone sticking around. Mario. So Mario had a good point. For a real graph, we're going to need for the actual talk. So what I'm doing is creating these examples and tracking the initial data, but we're going to build a function that just triggers each of these and creates a cold start for each one, and then tracks it, which means that we're going to be able to collect multiple results. I feel really good about this though, because frankly, I've seen this before. I've just never written it down and never created all this kind of data in any other context. So yeah, so we're going to need more tries for sure. And we've done that. You can see like in the containers, we've done multiple runs of the same exact payload to get multiple readings. There is an open ticket on, is it on GitHub, for cold starts for containers are really painful at the very first cold start, but after that, subsequent cold starts aren't as painful. I think that's super interesting. And we definitely saw that here. Right, you can kind of see that trend. Cool. All right, well, thanks everyone for sticking around. Really appreciate it. Again, if you have any questions about this or anything we talked about today on the stream, feel free to ping me on LinkedIn or on Twitter. My DMs are open. Happy to answer any questions. We'll do this again this weekend, probably on Saturday, where I'll try and write the invoker function for all of these, and we can keep these rolling and figure out what this data looks like in a longitudinal way. But I'm really pleased with this. I don't think this is going to change. I think there's going to be some variance, but I don't think this is going to change. Anyway, thanks again. Everyone have a great rest of your day, and chat soon. Oh, yeah, I can answer one more question quick. Yeah, what's your question? Thanks, Mario. Oh, if you want to just add, okay, you don't have an actual question. You're saying, could I DM you an unrelated question? Sure, why not? That's totally fine. Mario, yeah, thanks. Appreciate it. If you're liking this and you're going to AWS reInvent, please sign up for my talk. The schedule should be out this week. If you're not going to reInvent, the talk will be available on YouTube afterwards, and I can plug that for sure. I do want to watch this video on Twitch. Not a quick question. Yeah, shoot me a DM. Happy to answer. And I think the next stream we'll do, I want to talk about this video on Twitch. It's a great video. If you haven't listened to Julian Wood or Chris Greenwood, they're both incredibly accomplished speakers. Really, really interesting people to chat with as well. But this is a great talk, and they talk about all of the things that I've been discussing when we've been building Bun for the custom runtime or just general container images, and how this caching strategy can make our cold starts way faster for large surfaces, and then especially like custom runtimes. But that's all I got. I gotta get ready for my actual job. So appreciate it, everyone. Take care. Have a good one.